Welcome back to the channel. In today's video, I'm talking about machine learning from a conceptual point of view. So if you don't know what machine learning is and you're interested, this is the video for you. So the first thing I want to talk about is a simple definition. So what is machine learning? Well, it's a way to solve problems when you don't explicitly tell a computer what to do. So imagine you want to draw a line. Well, you would tell the computer exactly how to draw the line. You might say draw it from point A to point B, and you describe the points and it draws the line. But what if you don't want to tell the computer where to draw the line? Instead, you want the computer to figure out that information. So that would be a situation where a computer can look at some input values, use that information to make a decision about where to put the line, and then draw it. But you didn't tell it exactly where to put that line. The computer figured that part out. And we'll look at an example of that in a moment. But the two words in machine learning simply refer to machine, which is the computer that is solving the problem, and this idea of learning. And I don't see it really talked about too much other than like a mathematical way. But I want to look at what this word learning means in this context. So we'll get into this, but the simple view of learning is that it's an update process. So think about it as like a generic problem for yourself. When you start out, you don't know anything about a particular topic, right? But as you learn a fact or some information, you start to develop an opinion, but it's limited. You only have one data point, one fact. And it's really hard to make a good opinion with just one fact, right? So what if you learn another one and then another? And as you build the amount of information that you have available to you, you can make a more sophisticated, mature opinion. So just think about machine learning, again, as a way to solve problems where you don't explicitly tell a computer all the information that it needs to do that. There's some part of it left for the computer to figure out. So let's look at this idea of learning. There's this idea of functions and inputs and outputs and parameters that we need to look at. So really simply, let's just say that you have some input here. I'm just going to draw this with an eye. And then that goes into some kind of a black box. We don't know what this is. This is some kind of system. And then we get out of that our output. We'll just draw it with an O. So the input we know that, and then we run it through a system and we get some output. And what happens inside this black box is some kind of a transformation. And that's what we're trying to figure out. That's the model that we would like to know and understand. So so as the animal gets taller, you know, how does its weight change? Well, there is some relationship between those, but we don't know what it is exactly. And that might be different for all kinds of different organisms. So that's what we're trying to figure out. So the function is that relationship defined mathematically that happens inside that black box. And it really is that relationship between the input and the output. So in a more mathematical way, we might look at a formula you've probably seen before. Now this would be for a line. So y equals mx plus b. You may also see that like beta 1 x plus beta naught. So in both of these situations, we have our input, which is the x value, and then we have our output, which is the y value. And in this function, we have these parameters which describe the slope of the line, which is the angle. And then we have the parameters that describe that offset, that intercept of the line. So with that information, we can draw the line. Going back to the concept of machine learning, though, we don't know what those are. We can't draw the line if we don't have that. So we have to figure that out. What we do have is the input. and we can see the output, but we don't know that relationship. Well, why did it turn into that? So this is where the machine learning part can come in. The next question that we want to look at is, how does machine learning know what direction to go? So let's look for a moment at this situation of input and output, and in the context of a linear regression. And that's one type of machine learning. So I'm just going to draw a simple plot here. So this is our X and our Y, our vertical axis and our horizontal axis. And the X is the input. So that's our input, and the Y is the output. So for some value of input, we will get some value of output, and we get a data point right there. So going back to our example with an animal, if it's X tall, it is going to have a weight of Y. So that gives us our data point here. Let's say we have another data point over here, and another one over here, and another one down here. And we can start to see that, there may be a linear relationship here. So let's add a few more data points. And again, this is all made up, so none of this is real. But let's just say that that's our data set for now. The line that we could draw through there is going to pass essentially through the middle of that data set, maybe something like that. I don't know. So let's just say that that is the line that was learned by the computer, by the machine, to describe the relationship between the X and the Y in this case. Right? So what really is happening is these data points were observations. They were observed to exist. They were measured. They are real. This red line that I've drawn here through the middle of them is the model. It is the function that exists in that black box, and it has some parameters that are defined at this point. So there is a slope, there is an intercept, and you can get that information out after the analysis. But just looking at it visually, this is the line that describes the relationship between those parameters, or between those inputs and outputs. So how did it get there? Like, why is this line not something else? Let's look at a different color here. So I'll use this kind of blue color to draw another line. But let's look at a line that is obviously not a good fit. So let's look at this one, and you can just imagine that it goes way off screen. So that line doesn't look like it passes through roughly the middle of that set of data points. So why is it not that one, right? That's a good question. So the way that the machine learns the kind of correct line is that it's doing a process of optimization, and it's looking at some other function to try and minimize that. So we have the function that describes the line, but it's important to know that there's another function that is at play here that you don't see. And to think about that in this case, what I need to do is look at the difference between these data points and the predicted line. So here's another concept. Let's look at this. Let's look at this one data point right here. There is below that data point a point on that red line where it intersects. Okay, so for that given X, which is where these both lie, there is the actual data point that was measured, and there's the predicted data point of what this model thinks the value should be for that given X. So the thing to keep in mind here is that there's a difference between those, right? There's some amount of distance between the observed value and the predicted value. And that happens for every one of these data points. So there's some difference. Now this one's very, very small. This one has a little bit more. This one's about the same as that. This one's a little less. So these vertical distances to that prediction line can be considered the error. So the difference between the observation and the prediction. And this other function looks at the average of the square of those distances. So looking at that more carefully, what you can do is look for every data point and its predicted value at that same x. You can get the difference of that, which is this blue line that I'm drawing all over the place. So you get the, say, y value of a data point minus the predicted y value, which is the point on the red line, and then you can square that. If we were to do that for all of these points and then sum that up, so there's a sum, and then divide that whole thing by the number of data points, we would get the mean squared error. So that's the function that is at work here. So you're simply looking again for the difference in the data points to the red line or the predicted line here, and then you're squaring all those values and then summing all that up and then dividing all that by the number of data points. And that gives you the mean squared error. So the way that this line is drawn is in a way to minimize that error. So you remember that blue line that I drew that was just way off? You can imagine that the differences between the observed points and the predicted points is huge. So it's not a very good line. In this case, the red line passes relatively close to all of the data points, which makes it better. It's a good fit relative to some other line with huge differences. So the way the line is drawn, just to go back and summarize it, you are optimizing this other function, which we call an objective function. So as that gets closer and closer and closer to zero, your line is a lot better. So where can you draw the line so that this other function is at a minimum? And that's how you get this position of that red line. And so that's kind of how that machine learning process works. It's figuring out, the angle of that line, the position of it up and down, which is the intercept. And it's figuring out the best place to put that so that all of those little tiny differences are as small as they can be. So let's talk about what types of machine learning there are. So the big categories are supervised and unsupervised. So what does that mean? Well, supervised is when your data have labels. So if you have a data set of, say, produce like fruits and vegetables from the grocery store, you have already labeled some of those as apples, bananas, oranges, lettuce, avocados. So you may be able to do some analyses that use those labels and make some predictions. And so in a supervised learning situation, you would have that figured out already. You might have some characteristics in terms of data points about those, but you would also have labels so you know what that object is at that point. With unsupervised learning, you don't have those labels. And so you may be looking for patterns, but you don't really know what those might be at some point. So maybe you just have a collection of unknown fruits and vegetables, and you would like to group them somehow, but you're not able to say fruits and vegetables at this point. You just have maybe parameters like you might have the overall weight of it, you might have the overall shape of it, the color, things like that, but you might not have that label of a fruit or a vegetable. And so you can do predictions without those, but it's not quite the same situation, and it's not for solving the same types of problems. So in terms of problems, what can machine learning do? Well, generally speaking, I would say that machine learning is really good at working on classification types of problems. So if you want to group, say, people or like with this fruits and vegetables idea, if you wanted to perform some kind of clustering to group them together in some way, you could use machine learning for that. And it's also really good for describing relationships. And this is like for a regression problem, for example. Machine learning is good at being able to come up with a prediction for describing the relationship between inputs and outputs. That's it for today. Just a really high level overview of machine learning. I hope I was able to answer some of your questions. And please like and subscribe if you enjoyed this video. Take care. Have a great week.